Hello and welcome to my YouTube channel. In my previous video, I delved into the introduction to Pandas with Python part 1. Today, I'm excited to bring you part 2, where I'll be working with real-world data. Unlike part 1, where we utilize synthetic data for fundamental processes in Pandas, this time we'll be applying our knowledge to actual datasets. Stay tuned for an engaging exploration of practical Pandas applications. Let's get started. The first thing we're going to do is to import pandas speedy, and then I like to import OS because I want to set a condition. I am using Google Colab, so I want to set a condition within my notebook so that whenever I run the code from the beginning, it's not going to remount my Google Drive, because you use Google Drive in Google Colab. It's not going to mount it again. It's just going to check it if it's already mounted and move on to the next thing. So that is what I'm doing this. So I'm going to say import OS, and I'll specify the type and say the drive mounted path, because I could just use any name for this. I just like to use drive mounted path, and I'll set the directory called content/drive, then /my drive. I don't even necessarily need to add my drive. If I want, I could just stop at drive and say if os.path.exist, that is checking already, and then checking this, print, that is if that directory already exists, or like check if the drive is mounted already. Then tell me that drive is already mounted. So no need again. I just like to use funny stuff for my print statement. No need again, and just do that. Then I'll set a condition saying else if it is not mounted, mount it. So, and to mount, you say from google.colab import drive, just say import drive, and I'll say drive.mount, and I'll specify this directory that I'm mounting, and that's simple. Or I could just say this, since I've already declared it before. I could just do this and pass it here. Also, another thing that I like to do at the start of my work is I don't want you to show some warnings in this code so it doesn't disturb our process while we are doing our work. So I'm going to say import.warnings, and I'm going to filter out the warnings so that I can ignore those warnings. Warnings.filter warnings, and I'm going to pass in ignore so that it ignores the warning. Okay, and that's it. So then in the course of our work in analysis, we might need to make a few plots, and to make those plots we might need matplotlib. Import matplotlib.pyplot as plt, and we will also need Seaborn. Seaborn is a matplotlib and Seaborn. They are both like visualization tools or visualization libraries in Python. So I'm going to import Seaborn also. Import Seaborn as SNS, and that's it. So I'll run my code and see. Let's see if it runs or if I'm making any mistake. So the Google Colab is going to connect and it's going to check. Okay, so it says doesn't have exists as part of the attribute. So let me see. Okay, it is exists, not exist, and I'm going to run it. So it's not connected before, so it's going to connect. and that's it. So it's going to connect to my Google Drive because it wasn't connected before, and that's it. And it's going to move on to the import. You can see the step. It's like in our code in Google Colab is going to show us. So it's running this now. You can see this green symbol we've mounted, and for our warnings, it's saying invalid action, ignore. And what is happening here is now when you run your code, sometimes it is normal that you have errors, so you look into them very well. Where's the problem coming from? The problem is this ignore, and from what I'm seeing here, it is because this ignore is carrying capital letter. It's just a typographical error. You can see, so drive is already mounted, so no need again. If I didn't set this condition in the first place, when I run this cell again, it's going to have to like try to mount the drive and tell me to connect to the email again and like that. So I didn't want that. So when I run this cell over and over again and I do this, it's just going to tell me drive is already mounted, so no need again. No need again. And you might say, how am I running the cell? You can just press this play button over here to run cell, or you can press Shift Control Enter depending on your command / Control Enter. So if you are using Windows, I think it will be Control plus Enter. But if you are using MacBook, which is what I'm using, you just use your command button, Command Enter, and that is how I'm running it. So let's move to the next thing. The next thing I like to do is I have a path where I'm working, and I want to ensure that as I load my files from Google Drive, I don't have to specify the long path. These are the things you do to make your work a bit efficient. Okay, so I'm going to specify the path, store the path somewhere, so I don't have to always write the old path whenever I want to import something from my Google Drive. So this is what I'm going to do. Then I'm going to pass the mounted path. I could just pass this drive mounted path into it directly, so that I don't like write it again. I could just do this, my path, and I'll do plus, then add the drive that I am trying to bring in. So I'm going to have this, and I'm going to just do this and say my drive slash, I created a folder in my Google Drive called Learn with Meshach. That's my YouTube channel. So because this work is being uploaded to the YouTube channel, so Learn with Meshach. So remember the YouTube channel. That's a reminder for you to subscribe to this YouTube channel if you are yet to subscribe to this YouTube channel. This is a reminder for you to subscribe. So Learn with Meshach, just go down and click on subscribe button and click the bell notification so that you can get reminders when I upload new videos. So that's it, and I'm going to specify this. So I'm going to run the path. Now whenever I want to import something, it's going to import it directly. I just need to specify path. When I specify path, then I use the plus symbol in the path, then I'm going to import whatever I want to import directly without specifying the long path. So the next thing we want to do is to load our data set. Remember, the analysis we're going to be doing today is the analysis of global greenhouse gas emissions data. It is nothing that is so deep of an analysis, but it's an analysis that we're going to do to introduce you to how to do specific things in Pandas. How can you explore your data? How can you see things? How can you visualize a few things? Okay, that is what we are trying to do. Now we're going to load the data. So for the global greenhouse gas emission data, we're going to be looking at greenhouse gases like the N2O, the CH4, the CO2, okay, and of course the total greenhouse gas emission. And just a reminder is that from the data set that we are using, the N2O is N2O CO2 equivalent, and the CH4 also is CH4 CO2 equivalent. It is the values have already been converted into the CO2 equivalents of that specific greenhouse gas. So the first thing that we need to do is there's a need to get our data somewhere, right? And that is why I'm going to show you the data sources. I already downloaded the data, and I'm going to be showing you the data sources of where I got the data from. And I'm going to be putting that out here right now. So I'm going to show you the data sources. So data source, let me create a new cell for text. I'll say text, and I'll pass it into it. So these are my data sources, data source. And I think we should put the title of our analysis. I think that is going to be good. And the title of our analysis is, I'm going to just copy and paste it here, analysis of global greenhouse gas emissions data. So that's it. Then I'll create a new cell, and we're going to see. So these are these are the places where I got the data, the sources of my data. And for the greenhouse gas emissions data, I got it from here, which is our world in data. Then I got the population data also, and the countries of the world data. Now, it is important in our analysis because we might have to consider some interactions or relationship between population and emissions data, okay? To see, is there an impact of population on this emission? Then in countries of the world, that data set is going to give us the countries that we can use to, because in the greenhouse gas emissions data, there is they didn't just put countries, there are continents, there are other information that are there. They named them the entities. So we're going to be using the countries of the world data to filter out, okay, which one are countries and not like region or continent out of the greenhouse gas emissions data. That is one. Then two, in the countries of the world data, we have the area, that is the size of a specific country. They specified it in the data set. And we're going to be also looking at interaction. Emissions based on how big a country is, how much of impact does the size of a country have on greenhouse gas emission. And we're going to be asking all these questions and be answering them with pandas. And that's really interesting. We answer them with pandas and we plot them, just visualize them also using Seaborn, like the heat map, and also check some global trends. Just let's move on, and we're going to see what we are getting at. So the next thing we need to do is to load our data set. So I'm going to say load data. Load data, and I'm going to call this data frame and call it n2. Then I'm going to say equals to load data set, like I showed it the last time. It's just a pd.read, then you say underscore csv. And what I'm going to be doing now is I'm going to be specifying the path the other time. Then I'll say plus, because we already got a path in the beginning, this path. Then I'm going to specify it and say path plus. Then I'll specify the name of the file. In my Google Drive, I stored it at n2o.csv. So I'm doing the same exact thing to import the other, so I don't have to do it again. So I'm importing 5 data frames. So for this, I'll just change it to ch4 and say part.ch4.csv, and this is CO2, and I'll say CO2.csv. Then the other one is the population data, population. I called it, the file name is worldpopulation.csv. So it's world_population.csv. Now you will see that whenever there's a space between words, we're not just using them as space bar in our file names, or when we are importing our data frame. You can just use underscore instead of space, because it makes your data easier to filter, to write, because when there's space you could have some kind of issues. So to avoid that, it is important that you use underscore when you're naming your files, or when you're naming your data frame. It's just easy for you. Then the next thing is the countries. The countries, and we're gonna call it countries.csv. countries.csv. So now we've loaded a data. Let's run it and see if we don't run into any error. So the data has been loaded, and let's just see the data set. So if you look at the end tool, I'm just going to show it briefly for you to see. Now you can see in the end tool, we have the entity, the code of the country, the year, and the annual nitrous oxide emission in CO2 equivalents. That is what I was trying to point out the other time. Then when you check the ch4.ed, then you can see the column also, methane emission in CO2 equivalents. Then the next one is we check the CO2. Yeah, you can see that. So annual CO2 emissions, and that's it. So we'll move on from here. The next thing we want to do is I want to merge the data, because I want my end tool, my ch4, my CO2, I want them to be in the same data frame, And one of the things you would have known from the data set while I was checking them is that we have common columns. For columns in the data set, in the 3 data sets. We have entity as common column, we have code as common column, we have year as a common column. So I'm going to be doing my join, that is, I'm going to be merging them based on these common columns that I have. And that's what I'm going to be doing now. So I'm going to call this data frame and call it GHG in the moment. And what we're going to be using, like I showed in the last lesson on Introduction to Pandas Part 1, I said pd.merge, that is to merge the data frames together. Then I want to merge df n2o, the data frame of n2o, and the data frame of ch4. Now, I can't put the 3 at once. So I'm going to merge 2, then now merge the other one to it. Merge the other one to the first merge. So I'm going to be merging twice. I'm going to be using merge twice. So I'm going to be using a comma, and I say on, then equals, what am I merging on? Because I am merging on more than one column, so I'm going to store them in a list. This is what we use to show a list, or I think for people who write JavaScript, they call it an array or something. But this, like, it's a list or an array, whatever you want to call it. So this, because I'm using more than one column and I cannot just write like everything directly, they need to be in a list. So entity, that's a common this entity, and the next one is code. I'll just copy it so that you can know where I'm getting it from. The code, okay, it needs to be, it's a string, then comma, then year. That's it. So I'm merging based on that. So normally this is okay. I could just run it and df.ghg is going to match them. But I still have one more data frame that I need to add, and that I need to add, and that is the CO2. So to do that, I just need to do something simple. When I'm merging more than 2 columns, all I just need to do is say dot merge. Again, just like this process that I'm doing. Then in this case, I'm going to be merging all this. It's already a data frame of its own. So all I just need to do is this data frame, everything here, then I'm merging it into this with this. Then I'll just say df_co2, which is what I'm merging. Then I say _CO2, which is what I'm merging. Then I'll just do the same exact thing that I did here. So I'm merging on all these thing. Then I'm going to just pass it in and say on just the exact thing I did here. The only thing here is that I am merging everything here to this. Then when I run it, let's see. Okay. And that's it. Then let's check what we have. Then dfghg.head, and let's see what we have. So you can see, so we now have the CO2, the nitrous oxide in CO2 equivalence, the methane in CO2 equivalence, then the annual CO2 emission. Now we are making some level of progress. So what do we need to do next? What do we need to do next is to make this data suitable, like make it a bit clean. And what can we do to make this clean is we need to rename some columns because this is too long. All right, this is too long. So what we want to do is to do some renaming. But the first renaming we need to do before touching this path is to rename the entity into country. Why am I doing that? Is because though there's a way I could join entity to the country data without renaming at all, without having to rename it, but I just prefer it because it's easier. So what I'm going to do is I need to rename this entity column. So from this data frame, I'm just going to come next. So this is a way to show you how to rename a column, So I'm doing this thing so that I can show you these little things that you do in Pandas. Okay, so how to rename, we've touched on merge, and now you want to rename columns. Okay, how to rename columns. So how to do that is very simple. You just need to use rename, just straightforward. Then you open bracket, then you specify the column you want to rename. So in this case, you're going to specify it as a dictionary. In Python, dictionaries, they are key value pairs where what you want to rename will be the key and the new name that you are giving it is going to be the value. And that's what we are doing. So I'm going to say columns equals to, then I'm going to open it, a dictionary this way, and say entity. That's what I'm renaming, and I'm renaming it to country. So country, so that everything will store in itself. Like I said the other time, if you don't pass this parameter of in place equals true that I want to pass now, this is going to only rename it without storing it. It is not going to store it. But to ensure that the process I carried out will be stored in the data frame, it is important that I add in place equals true. And if you don't add in place equals true, there's also another way to do it. I could just use the name of the data frame. I could just use the name of the data frame exactly and store this into it. This is going to store it. Okay, but let me just go through these means. Say in place equals true. In place equals true. That is, I'm saying for every operation you're going to be doing here, as you are renaming the column, store it in that same data frame. So I'm going to run the code and let's check if the name has changed. .head, and you see we have it now as country. So let's check the other data frame. Let's check the other data frame, which is our population data frame, to see if we need to also rename the country column. Then we say df underscore population. Okay, not population. It's population. Then we are doing it .head, and we are checking it, and we can see that it is country name. It is country name. And what do we need to do in this case? We need to rename the country. We need to rename it from country name and put it back to country. So just exactly what we did here. You can just copy directly, and if you want to type it again, you can do that, and you replace it with the data frame here, which is population instead of GSG, and you need to change this, which is country name, change it to the country name, then you store it using in place equals true, and I'm going to run it. And when I check my population.head, now df population.head, you can see it's now renamed as country, and that is how you do that. Okay, so we're going to check our countries. When we check our countries, we're going to try to see if the colon is also named as country, so that we can have all of them in similar with similar names. So we're going to check the countries data frame. Okay, df underscore countries. For countries, then we say .head. If I didn't specify .head, it's going to show me a part of the head and a part of the tail. That is why, because I just want the head. So if I run it, it's going to show me a part of the head, you can see, and a part of the tail. So what I want is just a part of the head. That's why I'm using .head. Okay. Now it is already country, so we don't have to do any rename. So now in this country data set, we have a lot of columns. We have a lot of columns that are giving us good information that we need. But for this analysis, we are simply limiting what we want from this country's data set. We are limiting what we want from this country data set to just the country, the region, and the area. For population, we have another data set giving us information on population, so we don't need to repeat it. So we're just going to subset by having country, region, and the area size. We're going to be extracting that. So we're going to say df.countries. We use the same name, df.countries. Then we specify the data frame, df underscore countries. And what we are doing is we are subsetting. So normally if I want to select one column, I'm going to do this, and I'm going to pass in the name of the column that I want and say like country. I'll say country, and I'm going to be able to subset that, but that is not what I want to do. Now, because I am doing multiple columns, there's a need to also pass in a list into the selector of the data frame. So I need to pass in a list. So to do that, let me just clear this country and pass in another list. So it is in that list that I'm going to specify the things I want to select. So the first thing I'm selecting is the country. Then I am selecting the region, because we need the region. We're going to be doing some checking how a region has effect on emissions. The region, and okay, sorry, Control Z. Then the next thing we need to check is we don't need the population, but we need this area size, that is the size of the country. We need this area, and okay, it needs to be a string, and there we should be able to have a new df country data frame, a country's data frame. And let's see, now you see we just have these three key information. We just have this three key information. Now we move to the next thing. So what are we trying to do now is we have the population data. We also have the GHG data, that is the data frame containing all the greenhouse gases. To use it together, we need to merge the data frame containing all the greenhouse gases together with the population data. Also combine it with the country's data. So we're going to do it stepwise so that it can be clear. So we're going to merge again, and you need, by seeing something repetitively, is going to stick to your memory, and you can easily remember the next time that you want to do something with it. So we need to merge. So I'm going to use df underscore GHG as the same, because I want to go merge whatever I'm merging into the df underscore GHG data frame. Now I'm going to say equals to pd.merge. Okay, then df underscore GHG, that is the greenhouse gas, and that is that will be my left data frame. Then the right data frame, that is what I'm bringing to merge, is df underscore population. Okay, I'm glad Google Colab is suggesting for me. That's so good. Thank you, Google, for that. Thank you. Then equals to, so what am I merging on? What are the common things that we have between df population and df for the greenhouse gas. Now let's check the data frame again. Let's check this data frame again. We're going to check the two data frame. I'll say dot head. Now you can see, and I'm going to check population.head, df_gsg. No, population for population. Okay, dot head. So we're going to check it. So what are the common things that they have that could help us join them? So they have the year, they have the country. Okay, they have the year, they have the country. Now I want to join them based on the year and based on the country. Now there are possibilities that in the data set, when you look at the year, for Afghanistan, for example, they began to gather, the population data began from 1950, and for the greenhouse gas emission data, it is from 1949. Okay, now since we are, using the population from here, starting from 1950, what we're really interested in is how we can join them. So that means in our case, we might have to ignore the greenhouse gas emission in 1949, okay, and ensure that all the data we are joining together, that we have everything joining on the right row. And in this case, since there's no 1949 in the population data, it's going to be an automatic inner join. That is, if there's 1950 in population data, there's 1950 in the greenhouse gas emission data, so it's going to join on that because there's no data for 1949 since we are joining on country and on year. Okay, so that is what we are doing. So I'm going to delete this. So we want to join on country and on year. So it's going to be an inner join. That is what is common between the two in terms of their rows is going to be joined together. So let me delete this so that we don't just have .add in everything. So because we are joining on more than one column, so we do what we did the other time. So we create a list and pass in, we are joining on country and we are joining on year. We're joining on country and we're joining on year. So let's see what happens. Okay, now let's check it. Say df_gsg dot head. You see that now it ignored the 1949 automatically and joined from 1950. So that was what I was trying to explain the other time. It's an inner join. That is what is common between the two in terms of their rows. Is going to work. Whatever is not common between the two is going to throw it away. But if even we did like a left join, everything in the left will be retained, and everything in the right that is not on the left is just going to put NA on them. Okay, and if you do a right join, it's going to keep everything on the right that is in the population data set, and it's going to bring only the things that are in the right columns that matches the left column. Okay, it will take them from the left column to the right column and ignore those things that are not in the right column, for example, that are not in the population data but are in the greenhouse gas emission data. Okay, it's going to ignore them and retain everything in the population data while ignoring things that are in the greenhouse gas emission data but not in the population data. Okay, if you are doing that kind of merge, but in our case the default is an inner join. Okay, and if you do like a full outer join, it's going to just bring everything together, so you're going to have a lot of NA. It doesn't care if they match or not. In the places where they don't match, it's just going to put NA there, and that's it. So let's move ahead in our work. Now we've been able to have a greenhouse gas emission data containing our population data, containing the CO2, the methane, and the nitrous oxide, that is the N2O. Okay, now what we want to do next is to check our greenhouse gas emission data to see into it like the value count of the countries. we want to see the value count of the countries. That is, how many unique countries do we have and how many times do they occur in the data? How many times did they occur in the data set? That is the next thing we are going to do. And this is very important because we want our analysis to be balanced. We want our analysis to be balanced because there are chances that there's greenhouse emission data for a specific year for a specific country, and we don't have greenhouse gas emission data for a specific year for another specific country. So it's going to be kind of difficult for us to have a balanced analysis when we check trends, except if we are looking at it like on a global trend. But when we are comparing like things from a country to another country, it will be difficult, especially when we are grouping, okay, based on year, because some years are going to be missing out for some countries. So it is important that we have a balanced analysis. Okay, so let's check the countries that we have and the number of rows they have per country, that is the count of the occurrence of the country. And remember, since each row specify a country in a specific year, so that means if a country has less count, that means that number of counts is the number of years of data set that was gathered for that country, of data that was gathered for that country. So let's check. So we have this, and what we want to do next is we select the country because we want to check the value count. So we'll pass in the country and say dot value underscore count, value underscore count, and that's value underscore count, and that's it. Now when you look at it, for 72 years, because each row represents a year for a specific data set for a specific country. Now we have data for 72 years for Afghanistan, we have 72 years record for Norway, but for East Timor, we only have 28 years. Like we have 28 for East Timor. So, and if we check something, we want to check where what is the year that they began gathering data for East Timor. So we're going to make our analysis based on, because that means for all the years, East Timor doesn't have data for all other years, but we're going to use the East Timor as a basis for selecting our data frame. So we're going to subset our data frame based on the number of years available for East Timor. So we're going to check what year did they start gathering data for East Timor. So to know the first year that they started gathering data for East Timor. So this is how you subset, just to check before we do the final subset. Okay, so we're going to say df of GHG, the same data frame, and we do this and say df underscore GHG. Okay, and we do this and pass country into it. So we want to say show us the data in a data frame, subset the data frame and show us where the country is greater than or equal to East Timor. Okay, where country is greater than or equals to East Timor. Okay, but since East Timor is not a how do I put it now, since East Timor is not an integer, so we may not be able to use like greater than or equal to. So we just want to say, just show us where we have East Timor only. So instead of greater than or equal to, we're just going to say equals. Okay, then we pass in East Timor into it, and let's see what we have in the end. All right, now look at this. You will see that they started gathering data for East Timor in 1994. They started gathering data for East Timor in 1994. So what we need to do in this case now is we want to select our data only starting from year 1994 and ignore every other year, so that we now have data from 1994 to the end, which is 2021. From 1994 to 2021. That is what we want to have, so that we can have a balanced analysis. Yeah, there are some kind of analysis you want to do that you can use all the years. Yeah, it is good, but in the case of this tutorial, we're just going to use from 1994. So how do we do that? I'm going to call this as a subsetting data. I'll just say subset data from 1994 and above. Oh, I'm spelling subset. It's subset. Okay. Now I'll add code. You can add code or text. So I added text here. Now I'm adding the code where I want to have the line of code. So I'm going to call this data frame. I'll say df greenhouse gas. Now I want to use a different name. I'm just going to say 1994 to 2021. Then equals to the main data frame, which is the greenhouse gas. Okay. So what I'm trying to do here is I want to get where the year is greater than or equal to 1994. So year, but this is not going to work directly. I need to also have another subsetting, like to subset it inside, because if I do that directly, it's just going to give me true or false. And let me show you something. I'm going to clear this so that you can see. I'll just say equals to greater than or equal to 1994. Now, if you look at something, if I run it, you can see it's only showing me true or false, true or false, true or false. It is not giving me anything. So, but to do that, so that I can have the right thing, I need to wrap everything also within within the data frame. I need to wrap it around it, that same data frame. So I'm going to say greenhouse gas, and whatever I'm doing here is going to be an operation within this. Okay, so what I am saying now is that going to df.gsg data frame, wherever this colon is greater than 1994, give me those data sets. So you can see starting from 1994. Now all I just need to do is to store it. Then I can store it as df underscore greenhouse gas, then 1994 to 2021. And that's it. So everything is going to be stored here. Everything is going to be stored. So we have it successfully now. So, and we can check just like we checked the other time. We check using .head. Okay, and that's it. That's how we do it. That is how we do it. Now, if you notice something, the index is not correct. So because of how we made a subset, we have the index in another form. So that our index can start from 0, while we are subsetting our data, we can reset the index during the stage of the subset. So we just need to pass in that reset the index dot reset index, and if we do it directly, it's going to reset it, but there's going to be something wrong. Look at this. When we did it directly, it did the index reset, but it passed in the old index as a column, and we don't need that. We don't want the old index in our data frame. So all you just need to do that is a drop equals true. So when you do this, it's not going to add it as a column. So I'll run it again and say .head, and you see everything now seems perfect. Now in our country data, we need to drop one of the columns. We need to drop one of the columns that we don't need. So for example, I don't really want code. So just to show you how to drop a column, I don't want code. So I'm going to drop it. Then in this data set, I'm just going to come here and say .drop. And I'm going to specify the column that I want to drop. I'll say code and say axis equals to 1. Then to store it after dropping it, I'll just say in place equals true. Just like we did the other time. I'll say in place equals true, and we should have it. If we say this.head, so you can see that we don't have that anymore. Okay, so there's no code there anymore. Now we have our data set from 1994 now. So the next thing is, let's merge the country's data to the data that we have currently. So let's do the merge. All right, let's do the merge and see if it's going to work or if it is not going to work. Now let's join the country and say join country data. So we've been able to join the greenhouse gases together. We've been able to join the population data. Now we need to join the country data. So I'll just say join country data. Join country data. So let me just use a random stuff because something is not going to work. And I want to show you why it is not going to work, which is why you should pay good attention to your dataset. Now I'll say pd.merge. So I'm going to just say merged.df, pd.merge. Then I'll pass the data frame and say df underscore countries, which is the other data frame, and I'm merging on country because that is the common thing that I have. So I'll say on country, and let's see if it's gonna work. Wow, it worked. Let's check. It didn't return any error. Now let's see. Now look at this. Everything is empty. Why is it that way? Why is it that way? Why is it returning empty? Okay, now a lot of times when this happens, the join was done accurately. The problem here is that the way the country in the other data frame is written is different from how it is written in the other data frame. Okay, in our df.countries, let's check something. So we'll try to filter df.countries, the same country, and we'll try to filter the same country name from the other data frame. So let's do something. So now to check the data to see if something is wrong, so we say this. All right, now we want to check where this is equal to, I'm trying to get a random country, so where this is equal to let's say I'm going to use df where country equals, let me use Nigeria as an example. Let me use Nigeria as an example. I'm Nigerian, so I'll just say Nigeria to see what it's going to return. Now you can see it's giving me all the information about Nigeria. Okay, now I'm going to replace just the data frame, df.countries, and do this and say df.countries and look for Nigeria in the countries data set. Do you see? It returned empty. Same Nigeria, same spelling. Okay, and if you check df.country, you will find Nigeria in the list, it will be somewhere there. It is not an empty data frame. So what is happening here is that, okay, or should I allow you to guess it? If you could guess what could be the issue before I'm going to show it, you could put it in the comment section that I got it beforehand. Okay, so what is here is I try to check if, since Nigeria is in the data frame, right? Now look at Afghanistan. I think it's better to use something that can be easily seen. It's used on something that can be easily seen. So I'll try to use something like Afghanistan, for example. Let me use Afghanistan, for example, and search for this Afghanistan that you are seeing in the same country's data frame. Search for it and see if it's going to return it. Now look at this. Nothing. Empty. Now I try to add a single space in front of Afghanistan. Then I search for it. Look at it right there. So that means we have space in front of the country names in the country dataset and in the DF countries dataset. And that is where we are getting our issues from. So what we need to do is we need to clean the space in the countries dataset. We need to clean the space in the countries dataset. So that is what we need to do. So we need to remove the space in the column. So how do you do that? That's another thing that we're going to be learning now. So how do we clean the space in that specific column? How do we clean the space? So all we need to do is we just say DF countries, select the column, and we have DF countries. Then the next thing we need to do to clean it is we want to store it back in DF countries. That is, clean it and return it back. So we're going to say equals to the same thing, and we just pass in this string. We say str.strip because it's a string method. So we say str.string. So that is, go into the data frame and clean all the spaces that may be there. Clean every space that we have in the data frame. So I'm going to do that, and we're going to try to join the data set again. We're going to try to join the data set again, and I'm going to create this. So now that we're joining it, I will call it gsg underscore final data frame. Okay, then here I'm going to do that pd.merge again, just like we did it the other time. I'm just going to copy it from where we're trying to do the join. Okay, here I'm just going to copy the exact thing and use it. Then you're going to see. Now let's check our gsg final data frame, and that's it. Everything is joined. Everything is joined. So that's it, and we move to the next step. So to the next thing, what we need to do now is, after having our final data frame, we could see that we have some things over here like the annual nitrous oxide emissions. I mean, they are very long, and I would love to do some renaming to make them easy to filter when I need them. For example, changing these nitrous oxide emissions in CO2 to like N2CO2, and the methane to CH4CO2, the annual CO2 to just CO2. So something like that. That is the next thing that I am trying to do, or that we are going to do. Okay, so I'll move here to the next column and run. This is our data frame again. So just make it interesting. Let me use head so that I only have the top 5. Okay. All right. So that's the next thing I'm going to be doing. And just like the way we did renaming the last time in the other parts of our analysis, or I'll call it pre-processing in the other part, because everything we are doing now, we are still pre-processing our data. We've not really begun any analysis per se. So that's what we're going to do. So I'm just going to say here that I'm renaming the columns, renaming some columns. So that's our GSG. The data frame is our GSG final data frame. Then to rename, we still call, of course, the same thing, GSG underscore final data frame. Then we use dot rename. We want to rename those columns, and we pass in the columns that we want to rename. All right. And remember, I said we use a dictionary where the old name is going to be the key and the new name is going to be the value, because dictionaries are key value pairs. So in this case now, what we are renaming these. We copy it, and the value is going to be N2O CO2. So let's call it N2O underscore CO2. All right, then we put a comma, and we do the next one. which is going to be this one. We'll rename this annual methane emission in CO2 equivalent. So this is going to be CH4 CO2. So we'll pass in the value. It's going to be CH4 underscore CO2, then comma, and we'll rename the next one by going to annual CO2, and here we just pass in CO2. We just pass in CO2 as the name, and that's it. So if we run our code now, we're going to see that our data frame will be updated, and we can check using the .add just to be sure, of course, just to be sure that everything is intact. I always advise that you check, the result of whatever you've done to be sure that you've done the right thing. So we have the N2CO2, CH4 CO2, then we have the CO2. Okay, so I can clean that out of what I'm doing. Okay, now after we have this, it is important that we do some mini data exploration. We do some mini data exploration to just understand what is there about our data frame. What is there about our data frame, or what we can say like the data set we are working with. What is really there about it? And the first thing you do here, now we are starting the I'll call it like we are starting the analysis proper. And the first thing we are doing is to just do some mini exploration. So let me call this like analysis. Let me put it in a note. The analysis. Let me say the analysis. Okay, and I'll just make it big. So we start with mini exploration, and I'll just comment this guy over here. Start with mini exploration. So there are some things you do in the beginning when you want to do your analysis, and you do those things so that you can have some understand things about your data, and that's very important. So the first thing I'm going to do here is I have my data frame, and I'm going to use the first thing called .info. Like, just give me the information about the data set I'm using. Give me the information, and this is it. So here now you are able to see all the columns in your data frame. You are checking here, are there any null values? Do we have null values? The data types, object, integer, float, and like that. Okay, so you're checking that. Although there are specific things that you can use to check data type. You can use the .d type to check data type. I showed that in the introduction to Pandas, the part 1. You can use the .d type. You can actually, we're going to check how to know missing value. Even though when you use the .info, you can see that it showed that everything is non-null. We'll actually do this again to just check if we have missing values in our data. But before that, let us do some descriptive statistics. Like, let's describe our data. All the places where we have numerical values, we want to just see some simple statistics about them. Like, for example, the count, the mean, the standard deviation, the minimum value, the maximum value, what I will call now like the division in terms of the percentiles, the 25th percentile, the 50th percentile, the 75th percentiles, like that. So, and to do that, you don't need to write any long code. All you just need to do is, let me call this, I'll say do descriptive statistics. All you just need to do is use a very simple method of Pandas and just say describe. I think they took it from the word descriptive. Something like this. So funny. Then just say describe, and that's it. As simple as that. And it's going to give us statistics of what we are working with. And you can see that the mean of the date is 2007. The standard deviation, of course, under the year, the N2CO2 and everything. And here can help you, have some visualization about everything that you are doing. Like, you can visualize them, of course, in table form. If you want to know if there's a minimum value, there's a maximum value. And here can also help you check some kind of anomaly in the data. Maybe you want a data set that is well distributed in terms of maybe a normal distribution that you want. You can actually check from here based on the mean value, the standard deviation value. You can just see a lot of things from this. I mean, this is a very basic statistics on your data, just giving the description, and you can see through your data set, and that's just it. So the next thing we're going to do is we're going to go into checking for missing value. I'm going to go into checking for missing value. And how do we check for missing value? That is what we are doing next. So checking for the missing value. So I'll just say code, and I'll do this like hash and say check for missing values, check for missing values. And to do that, I have my data frame, and you use the function is NA. So if you say it's NA and you just do this, if you run this, you're going to see the output. It's just going to show you that false, true, false. Is going to show it in terms of a boolean, like a conditional, like, okay, it is false. That is, there's no missing value here, no missing value, no missing value, no missing value. But I mean, if you are dealing with like 10 data of like, let's say 2 columns, 5 rows, I mean, you could see, oh, okay, it's false, so no missing value. But for you to see like everything, for you to be able to see it together, you can add another thing to it, like another function called sum. So what it's going to do is that it's going to look through the old data set, or the old data frame, as you might choose to call it. It's going to look through the data frame and tell you this part is like there's missing value here. It's going to sum it up for us, and you can see, so column by column. So you see in country, say no missing value in the country, no missing value in the year, so everything is 0, so there are no missing values. So that is what you do. Now in the case where you have missing values, what are the things you can do? Although we don't have missing values here, but what can you do if you have missing values? There are 2 things I'll suggest, even though there are other, I mean, more of course complex things that you can do when you have missing values. The first thing you can do is to fill the missing value with a specific with another value. So depending on the kind of analysis you are doing, if it is not like analysis that is like very centered on the specific value of in a column, you can just fill it if it doesn't affect, if it wouldn't affect the result. Sometimes you can fill it with 0, sometimes you could fill it with 1, like, okay, I just want to fill everywhere we have missing value with 1. Sometimes you can fill the value with, for example, you can say in that whole column, take the average of the column and use the average value, or what we call the mean value, fill it with into everywhere that we have NA. So you can say in N2O CO2 now, everywhere we have NA, you select it and say fill NA with the mean of N2CO2, and it's going to fill it. So that's another thing you can do. You can fill it with 0. Anything you choose to do, you can do that. And the second thing is that you can just drop the row. The complete row where you have missing value, you can just drop the full row. Okay, but to do that, we don't have any missing value, but I'm just going to show what you can do. So if I want to fill, let's say, the NA in our data set, I'll just use, just from the word, just say fill NA. Then the next thing you pass in is you pass in the value for the NA. You can pass in the value that you want to fill it with. You can pass it in, then ensure that you use in place equals true. In place equals true. If I run it now, of course, it's not going to work because we don't have NA in our case. So you can fill in the value, and you can also, remove this and just use a condition. Maybe you want to use the mean value, then you can write the function to get the mean of that specific column and fill it in, and that's it. So that's how you do that. So I'm going to return this, how to fill in a value. Then another thing you can do is to drop. You can just drop all the rows where you have NA and just say drop NA and open bracket, and remember, use in place equals true, so that when it drops it, it stores it. Okay, and that's it. That's just what you do. Those are the 2 ways I suggest to undo missing values, basically. But your decision on how to undo missing values will be based on the analysis that you are doing, the peculiarity of the data set, the peculiarity of the result you want to get, the peculiarity of the overall analysis question will help you to decide what should I do Should I drop it? Should I fill it? If I'm filling it, what should I fill it with? That is how you make that decision. So there's nothing is written on stone on how to handle missing value. It all depends on the data you're working with, the output you are trying to get, and the overall analysis question. Okay, so that's what you do. And the next thing you can do also is that in some cases you have some data set where you want to see, do I have any row that is duplicated? Do you have any row where all the values in that row, they are all duplicated? And how do you check for duplicate? So these are the things you do to investigate your data sets. So I'll say check for duplicates. I'll say check for duplicates. Just say check for duplicates. That's what I'm going to call that. And I'll just use the command duplicated, just the way it sounds, duplicated. And I'm going to do this. So if you do that, it's going to tell you false, 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 like in general. But for you to be able to see the sum, to see which I have, like, which part, how many of my rows are duplicated, how many of the rows are duplicated. Here now we have about the length of the data is like 4,928. You can't see everything to see which one is true, but by adding sum, you can easily see the count. You can see it says 0. So none of the rows are duplicated. Okay, it is very important because there are some analysis you don't want duplicate. But in another kind of data set, maybe you are working with some financial data set, there might be situation where if you let's say you are checking the transactions of a specific customer, okay, and you are missing, let's say, the date and the time column. Okay, so there's a possibility that the same customer is doing the same transaction within the same day, and the only thing that might tell the difference is the date, the transaction ID, and the date, the transaction ID, and maybe the time. Okay, but in the same day, there's a possibility that the transaction ID and the time is missing. Okay, and that data will look like a duplicate. And if you go and like maybe drop the duplicates, that might be an issue because truly the customer did 2 transactions. So you need to check all these things, that it is not in every kind of data set that you drop duplicates. You need to check the peculiarity. In a financial data set, that same customer is doing the same transaction, probably the same amount, the same time, doing it into the same account for the same purpose. But the difference might just be the time, the date, and the transaction ID. And if those things are missing, there is going to see it as duplicate. And if you remove it, you'll be missing a transaction from that specific customer, and that will be a terrible thing. So like I said, the things you do, they are peculiar to the task at hand, the data set, the overall question that you're trying to answer from the data set. So if you have duplicates, what can you do? Let's say there's duplicates, what can you do? So what you do is you say drop underscore duplicates, just like the way we dropped n here. So just say drop duplicates, and that's it. And it's going to drop it, drop duplicate. So in our case, it's not going to work because we don't have any duplicates. You just return our data set, and that's it. So that's just all to be done. Now let's go into the analysis. So everything we've done before, they are like the pre-processing. Okay, and within our analysis task, one of the tasks we are going to have also would be to do a little kind of pre-processing, which is like reclassifying a part of our data set. And we are going to see that. So I'm going to create another like text cell and just call it analysis task, analysis task, analysis tasks, analysis tasks. Okay, all right. Now in our analysis task, I have written some kind of like questions that we're going to be answering, and we're going to follow each how do I put it now? We're going to follow each question. We're going to follow it one by one. We're going to follow each question one by one. So we'll move to the first question, and after the first question, we'll move to the second question. And I have about 15 questions that we're going to be answering in the whole analysis. Okay, those are like the tasks that we're going to be doing in the whole analysis. And I hope you learned something. So everything we've done before, they're like pre-processing, so that we can have a data frame where all our work will be done, that we're doing all our work on. Okay, that's everything we've done before. So we've done the pre-processing, and now we are moving into the analysis proper, even though there are tasks in the analysis where we are going to need to like do some manipulation on some of the columns. Okay, so the first question in analysis is to reclassify the different populations and drop other population columns that are not in use. So let me use this text and say question 1. Now saying reclassify the different populations, okay, and drop other populations columns not in use. Now, since what we're trying to do is column related, first we need to see the column. What are the columns in my data set? So I'll say ghg underscore final.df, then just say dot columns straight up. Just do this and you're gonna have all the columns. Just say dot columns. Now you can see all the columns that we have in our data set. So what I'm trying to do now is, we will see that the population part, where we have population, we have the population which is like the total population, and now we have another one that is like population of children under the age of 1, children under the age of 5, children under the age of 15, children under the age of, every they categorize the population in that form. But I want to reclassify them so that we're just going to have 4 categories of population. 4 categories. That is children under the age of 0 to like 29, 30 to another age group. Okay, I'm going to show what I've written in that light on handling the question. So I'll say question 1, and I'll create another cell over here where I'm going to be showing how to classify the population that I came up with, how to classify the age group. So we're going to classify them into like generations. We're going to classify them into generations. Okay, now, so this is what we're going to be doing. Just click out so that we can read clearly. So what we're going to be doing is we're going to call generation A. So that is from A to D. So where generation A is going to be 90 and above, D is 0 to 29 years old. Generation C is 30 to 59. Generation C is 30 to 59. Generation B, they are 60, people of 60 to 89 years old. So that is how we're going to be doing our classification. So that's how we're going to be doing our classification. And to do that, we're going to need to add, of course, create columns for the generations. So that means for everything we're going to be doing under generation D, we will need to, how do I put it now? We'll need to like create a column called generation D within the GHG final data frame. So what we need to do first, what we need to do first is to reclassify them. We just say, we'll call it generation underscore D. So we can say generation underscore D. So we do D first. That is 0 to 29. And what do? It's very simple. So what we need to do, we are not just doing it directly. When we classify the generation, their population, so for a specific generation, what we are going to be doing is we are going to be converting it to percentage, because we want to like get the fact that a specific percentage of this population, for example, you say Afghanistan, the specific percentage of their population is from, how do I put it now? They are from the generation D, or 65% of population of people in America, they are in generation, let's say generation A. Maybe they are all 90 years and above, so we have more people that are 90 years and above in America, or something like that. But of course, that's not valid. That is not true. Okay, so that is the first thing we are doing here. So we say, now to do that, we combine the ages. We want to combine the ages, that is every column that fits what we are trying to do. So for generation D now, we need to bring together children under the age of 1, that would be like 0, from 0, children from age 1 to 4 years old, children that population age 5 to 9 years old, then age 14, age 10 to 14 years old, age 15 to 19 years old, then age population age 20 to 29 years old. So we're going to sum them together, and that will give us the generation D population, that's 0 to 29. And we're going to follow that way also with how do I put it now? We're going to be following the same thing for the other generations. So to make things quick on how I reclassified, I wrote this because it's a bit long. So I did this here already. So now for generation D, you see, age of 1, everybody. So we'll put them into a list, and after passing them into a list, of course, within the data frame, then we did dot sum and passed in axis equals 1. Axis equals 1, note that all these columns, we are summing them on the column axis. So axis 1 is column Y, axis 0 is rows. Okay, then what are we doing next? To convert it to percentage, then we divide it by the total population, which is population. Then we multiply the whole thing by 100. That is how we get the percentage. So we did it for these two, generation C, people from 30 to 39, 40 to 49, 50 to 59. Those are the people in generation C, and we got that right. So we did the same thing. We sum it on axis 1. We divide everything by the total population, multiply by 100, just the way you get a percentage. Then we did the same thing for generation B, 60 to 69, 70 to 79, population age 80 to 89, the sum, axis equals 1, and times 100. Generation A, we did the same thing, people from 90 to 99 years old and people older than 100 years old. They are classified into generation A. We are doing this because we want to kind of see the impact of generation. Like if there's going to be some part of the questions where we're going to see if the generation that dominates the total population, if they have an effect on the emissions of the country. So if a country has 65% generation D, that is younger people, they have young people, how does it affect the emissions when we compare with countries where they have more of generation C, where people are not a bit young but they are more of adults? So this kind of relationship, this kind of comparison, it's good for our analysis to see, oh, so there's an impact that the generation of a population, their age group in essence now, the impact it has on the total emission. Maybe you can say because they have this specific amount of generation, so they are producing more of this kind of resources, they are doing this, and that's why the emission is increased. Or if it is the other way, this is why they have lower emissions than the other categories of countries. So, and that is it. So when analyzing data, you need to think through it. You need to begin to look into, okay, what can I use to compare what? Okay, and that is how you become critical. How does this impact this? How does that impact this? And that's how it is. Okay, so now I will run a code so that we can see. So that's run it already, and I'm going to check a data frame. I'm just like doing this just to be sure. Maybe I'm very skeptical if something works or not. Okay, and you can see we have generation D, generation C, generation B, generation A, and like that. And that's it. So what do we do next? So we've been able to achieve the first question, which is the generation questions. We've been able to achieve that the questions which is the generation questions. So now for our analysis, everything we need, we need the country, we need the year, we need, of course, the emissions, we need the population, we need the region, we need the area in square meters, of course, the area size, then the generations. We want to ignore every other thing in our data set. Why are we doing that? So that we can have focus when we load the data frame, so that we can have focus whenever we check. We have just the columns that we are working with, and it will make our life very easy in analysis. So everything we are not using, we're going to drop them, and the things we are using, we're going to select just those things. So there are two ways to do it. You can select the columns you are not using and drop, or you can just subset by just selecting the column you are using and storing it into a data frame, and that's it. Very simple. So it's just to make life easy. So that's what I'm going to do next. So the columns we are using, moving forward, I'm going to do that and say equals to, still storing in the same name, and I'm just going to be selecting the columns that we are using. So for me to see all the columns that we need easily, let's just do this again. I'll just say dot columns. Okay, and we'll run it to see. So we need country, we need year, we need it up to population. So I'll pass it into the list. Up to population, so we need all this. So I say comma, then we need region, from region to this, to generation D to A, we need these two. Okay, so just to be clear, okay, something is missing here. All right, so we're gonna run it to see, okay, everything is done right. Then we can check again. I don't know, I just like doing this. I just like checking. Okay, then so you're going to see now, instead of having this wide data frame, you're going to have something that is very focused. You can see very focused, everything from country, year, into CO2. So you can see everything clearly. You can see everything clearly. Okay, now after doing that, we need to move to the next question, and the next question is something very simple. Of course, question number 2. The next question is something very simple, so I'll call it question number 2. So set, and I'll say 2. And what is the question? How many countries are included in the data set? How many countries are included in the data set? So how do we do that? We just want to know the total number of countries that are in the data set. There are two ways we could do this. Of course, there are also one thing you must know in when using pandas is that, or programming in general, is that there can be, you know, hundreds of ways, tens of ways, multiple ways to do the same thing. But I'm going to show 2 ways that we're doing it here. So I will call the data frame, which is GHG final df. So I can select country. For example, say the country. Oh, sorry about that. Then country. We have country and dot value counts. Okay, this is going to give us the total number of unique countries. So we have all the countries, and you can see we have 176. So this length will tell us that is the number of those are the number of countries that we have in the data set. But another easy way to do that is very simple. So you can do this same thing. You can do the same thing, but with a different method. So we can do it with a different method. Then just say n unique, and see 176. So it just goes into country and showed us how many unique countries are there, how many unique values, n unique. And why are we using n unique is because in our data frame we have the countries repeated multiple times. So instead of counting the number of rows that we have, it goes to check what are the unique values that we have in relation to the country column, and that's how we are able to get that. So the next question that we are going into, so we are using the data to answer questions. Now the next question we are going into is that we want to know what is the global total population for each year. That is, in each year, what is the global total population? So let me add the question as number 3. What is the global total population? It is very important to know that the global total population for each year. And this is where we're going to be using something really interesting, which is the group by function in Pandas. The group by, that is, we're going to group everything by the year while summing the population for each country in each year together. very direct and simple. So we select GHG final df dot group by, and we select year because that is what we are doing it based, because for each year. So year is going to be the index, so it's going to be indexed based on the years. So of course it's going to be indexed, it's going to be grouped by the year, and that's how it works. But what do we want to know as the value that we want to see in total? Sometimes it could be what is the average population per year, it could be the total population per year, and the question here says total population. So we select the population colon. Now you see the difference. What we are grouping by is within the group by function, and what we are trying to sum or average, the value we are trying to get, is passed in braces, just like the way you create a list is passed into it. It's different from this bracket and these curly braces. Okay, and that's that. So what do we want to get? We just don't want to group year by population ordinarily. We want to know the total. We want to know the total. So we say dot sum, that is sum everything per year, so that we can get total population per year. And we run the code. And we're going to see from 1994, you can see the year that we have. And that's it. That's it. Okay. Now, we want to now answer another question, which is, we want to know which countries where people under the age of 29 are greater than, people under the age of 29 are greater than 60%, are greater than 60%. That is another thing that we want to check. So we want to select countries. So we want to see, okay, countries where people, we have young people, more young people, they are greater than 60% in those countries. So we check our code. Okay, let me create a text, and this is going to be the question. So we're saying select for. So now select countries where the average population of children are under the age of 29. That's if people under the age of 29, they are greater than 60%. So how do we do this? This is where the use of the generation comes in. So if we go back, we see how we classify the generation from the note we use. So you see that generation 0 to 29, they are generation D. So people under the age of 29, they are going to be under generation D. So what we want to do is going to be generation D. It's going to be generation D. So to achieve that is we'll select, of course, the generation. We're dealing with the average population. Okay, we use the mean. Then we'll see how we can get the country, how we can query it to know which country how is the generation D greater than 60%. Okay, we've converted the value of the generations to percentage already, so we don't need to do that again. We can just do it directly. Now, the first thing we need to do is let's subset our data based on generation D. So we just say GHG, I'll call it Gen D equals GHG underscore final df dot, then we're going to be using the group by, like I said the other time. So we use the group by. So in this case, we are interested in the country. We just want to know the countries where we have, like, generation D, the mean of course, the average population, So then we get generation D from the data frame, and we're going to say that mean. So it's going to go into generation D and do the mean of the percentage to let us know where the average population of children under the age of 29, they are greater than 60%. So I'm going to run it and see what we have. Okay, so let's check what we're going to have. Another way to do this is to always have, after your code, another thing you could do is within the same cell, just say .head to show, and okay, and that's it. So it's showing us generation D dot main. So because I used .head, it shouldn't show me the top 5, but there are more than that. So that's it. So we have all this. We have all this for the 176 countries. Okay, but here now we've not answered the question. We are only a step forward to answering the question. We're only a step forward to answering the question. Now, for me to query where the generation is greater than, of course, generation D is greater than 60% of the population. It's like 60% and above of the population. So what I need to do is there are many ways to do this, but what I want to do is I want to do it that after doing my grouping, what I'm going to get in return is a data frame. You can see what I have here is not a data frame. Okay, but what I want to get in return, a data frame. So how do I do that? So I'm going to do the process again, the process of my grouping. I'm going to do it again, but because I want to return a data frame, there's something I'm going to do. Within my group by, I'm going to pass in another, how do I put it? I'm going to pass in another parameter, and that parameter is going to return a data frame for me that I can easily query to answer my question. Okay, so within the group by, what I'm saying is that return a data frame of generation D showing just the country and the generation, and that's it. That's all I need. So I'm just going to say comma within it, and I say as index. So I'm saying return it back to my data frame where the country is not the index. The index is just the regular index number. So I'm going to say as index equals false. So as index equals false, and that's it. So when I do this, it's surely going to return a data frame for me in the end. So when I check it, you can see when you check, we use a head because I don't want you to give me long stuff. So you can see it returned a data frame compared to what it returned here. You see the difference here and there. So now we can now query what we want to query directly from generation D. There are other ways to do this, okay, but I'm going through this process so you can just see how to think about it a different way. So within generation D, I'm not going to say this generation D, the data frame of generation D that we created. Okay, generation D, I actually wanted to change it to like DF. Let's make it DF, but it doesn't matter that much. It doesn't matter. So let's just leave it that way. So I'm just going to say GHG. This, I want to subset this, and I'm just going to use. Then what am I doing next? What I want to check is I want to check where generation. So it's going to return countries where the generation D, they are greater than 60%. So I'm going to pass generation D, and I'm going to say greater than 60%. If I want to check if it's greater than or equal to 60%, I can do that. But here we're just saying greater than 60%. So we say greater than 60 because we have our value in percentage already. Then we're going to check. Let's see what it returns. So you see, so out of all the countries, 79 countries, which I mean the row represent the countries, 79 countries have their population, the young population, dominate more than 60% of the population. Isn't that amazing? So we've been able to answer that question. So we move to question 5. And what are we doing there? Okay, I'm going to copy the question here. Let me put 5 at the back. That's question 5. Question 5, then I click on code. And what are we trying to do in question 5 is what is the total GHG emission per country and per year? Now look at the question. Total GHG emission per country and per year. But if we load our data set, like the GHG emission final, you will see that the GHG final dot head, you notice that we don't have anything like total GHG emission in our data set. We don't have anything like that. We don't have total GHG. So what do we do? That means we need to create a colon for total GHG, and that will be the sum of this, and this. That is the emissions: N2CO2, CH4CO2, and CO2. So it will be the sum. That is total GHG. So how do we do that? Simple, just like we did the sum of something initially. So let's scroll down and just say, let's do this. Then GHG final. Okay, then we subset that, like create a new colon. Let's call it total GHG. We're going to call it total GHG, total underscore greenhouse gas. So total greenhouse gas equal to same thing. So what we are doing here now is we want to do sum, and since we are passing in multiple stuff, so we are summing on N2CO2. So we'll come here. I'm just going to copy it so it can be exactly. So we're summing these three. So I'll pass it in, and I'll add. All I just need to do is highlight, then click on your the quotation that is required, and I'll put a comma, and that's it. And I'm going to say dot sum, and I'm summing on my colon, which should be axis 1. If it is on row, it's going to be axis 0, and that's it. So I'm going to create my new colon. I've done that, and we can now check. Dot head again, and let's see, we have our total GHG now. So we can now answer the question that we need to answer. So we want to get what is the total GHG emission per country and per year. The total GHG emission per country and per year. So we just say per country, so we do it per country. We also do it per year. So this is going to give us this. All we just need to do is to group by using group by, but in this case, okay, but in this case, all we need to do is to take our GHG final, then pass it here, and we use group by, and passing country, and total GHG. That's what we are using. We want to get the total. So in this case, it's going to be dot sum, right? It's going to be dot sum, and we're going to see what our output is. So you can see this is our total GHG dot sum per country. This is the total GHG per in Afghanistan all through the years from 1994, the total for Albania, and like that. So we move to the next thing. We just copy this exact thing, and we just change the country to year. Just copy this exact thing and change the country to year, and year. That's it. And we get the emissions per year. So you can even see some kind of trend in total emissions per year, going from 3 to 4 to like that. So, and that's it. So now we can move to our sixth question, question 6, that we're trying to know, what we're trying to learn about our data set. Okay. Now, what is the average value? I'm trying to get a text, not a code colon. So we have number 6, I call it number 6, and we're going to answer the question. Also, this question can be answered using group by. So we want to get what is the average value of N2CO2, CH4CO2, and CO2 and total greenhouse gas emission for each country. So how can we get that? Very simple. The same way we use group by. Now we say GHG final DF. Now when we are grouping, we are going to do it in a different way. So we say group by country, that is, we are saying for each country. So we want to use country will be the index of the grouping. So we have this, and we're now going to pass everything here into a list. The total GHG is going to be passed into a list. N2CO2, CH4CO2. Of course, I'm going to clear this and then use the right name, comma, then use the right name here. I think we did it as GHG. Then I'm going to do it the right way. So since we're trying to check the average, not the sum per country per year, we just say dot mean. It's the average, and that's it. So you can see we are able to have the average per country, the average emission per country. So from here now, we will move to question 7. Question number 7. Okay, I'm trying to get a question into this. And what we are doing now is, here's our code. I'm going to pass it in as a text. So question number 7. So what is the CO2, CH4, N2, and total emission per capita for each country in each year? Per capita for each country in each year. So what we want to do before we do whatever, make the next step, will be we need to get the CO2 per capita. And per capita means what is the CO2 for, of course, a specific year in a specific country divided by the total population. So that is what it means, like per capita. So that's what we are trying to do. So all we are trying to do is to create a new column where we're going to have CO2 per capita, CH4 per capita, N2 per capita, and total greenhouse gas emissions per capita. So we have those new columns added to our data frame. Then we can easily see it. Okay, so that's how we are going to answer this question. All right, so we create a new column, say GHG final DF. Then we start with CO2 and say CO2 per capita, CO2 underscore per capita. Okay, let's use capital letter and say per capita, not capita. CO2 per capita. Then we're going to say equals to, then we divide the total CO2 that we had before. Then we say GHG final DF, get the CO2, then divided by the population. So that's it, divided by the population. GHG underscore final DF, then population. Yeah, that's it. That's how we get that. I think I need to clear this. That's how we get it. So I'm going to do it in multiple places because I don't want to repeat the same process for N2O, CO2. I'm just going to do this. Yeah. Then I'll just change it from here to N2O. Here is going to become CH4, I think. Okay, CH4, then N2O, then total GHG. N2O and total GHG. Then I'll say total greenhouse gas. Total greenhouse gas. And I will change whatever I have here. This is going to be CH4, and this is going to be N2O, and this is going to be total GHG from what we had in the column underscore but small letter GHG. Then we can run and throws an error. Okay, so when we check it, the error that we have is CH4. Okay, it's not just on CH4, it only returned that error on CH4. We're going to check. So it's the naming, it is the naming. So we need to check our naming. You can see the naming of how we named CH4. There's underscore CO2 and underscore CO2 on the N2O. So when you see errors, just check, don't be frightened. Okay, but it can be frightening sometimes, by the way, but it's not a big deal. So all you need to do is come to here and pass CO2 is just a naming issue, and CO2, and when I run it, I get the accurate thing. Then I can check my data frame, and we're going to see that we have all the columns. So this is the stage for per capita and so per capita for each year and each country. So we've been able to answer that. We've been able to answer that question. So we move to question number 8. Question number 8. Got the 8, and yeah. So the question in number 8 is, what is the emissions of the top 5 countries with the largest population and top 5 countries with the lowest population in 2021? In 2021. There's a way we can do this in one line of code, but I wouldn't go through that route because I want you to get everything clearly. So I'm going to do it step by step. So I'm going to do a subset all the 2021 because the question is in 2021, not in all the years. So from GSG underscore final df, I want to get where everything is 2021 based on the year. So I'm going to say GSG underscore then final df. Then I want to get where the year is equal to 2021, and that's it. So I have my GSG 2021. Then just to show you something again, like I showed the other time, when I run it, you could see that the index is not accurate. So I need to use the reset index, reset underscore index, and just showing what I did previously. When I do that and I run this, you're going to see that it created a new column for index, but I don't want that. So what I'm going to do is just to pass in drop equals true so that it doesn't create a new thing for me, and that's it. So drop equals true, and when I do this, everything is coming normal as expected. So what we need to do in this case is just to use sorting to answer the question of what is the CO2 exogenous emission for the top 5 countries. So we want to get the top 5 countries with the highest values in terms of like the top 5 countries with the largest population and top 5 countries with the lowest population. So that's what we want to know. We want to know their emissions. The top 5 countries with the highest population, the top 5 countries with the lowest population in 2021. So what we need to do is to sort on population. So to do for the top 5 countries, with the highest population, so we just sort based on population. So we say for top 5 countries with highest population, then we say greenhouse gas, GSG. Okay, we're working with 2021, so we say 2021 dot sort values, then we say population. We're sorting on population. Then in this case, normally when you don't pass this parameter I want to pass into my sort, I'm not doing sort index, I'm sorting on values, sort values. If you don't do this, you are going to have how do I put it now, you're going to have everything in ascending order, but I don't want to have it in ascending order. I want the highest population first. So I'm just going to pass in this saying ascending equals false. That is, give me in descending order, not in ascending order. So I'm going to run that, and that's it. So I want the top 5 countries, right? So now that I have it, these are the countries and their population. You can see in order. So I just want the top 5. So I'm going to say add 5. And that's it. You can see I have the top 5 countries with the highest population: China, India, United States, Indonesia, Pakistan, and like that. And that's it. To get the one for the lowest population, I just copy the same thing, and I'm only changing one thing for countries with lowest population. countries with lowest population, for countries with the lowest population, for countries with the lowest population, I can change this to true or just clear it in total. We're going to see that. You can see this is a country from here with the lowest population: St. Helena, then Tuvalu, Nuaru, Cook Islands, Palau. I'm just hearing many of these countries for the first time, by the way, some of them. Okay, this is interesting. I'm also learning something while teaching something. Amazing. So that's how we do that. So I've been able to get that. So if you don't want to use the head and you want to still sort based on false, you can use the tail. So let's say it's in descending order, is equals to false, right? So now I still want to get these values, so I can use the tail. See, so it's going to bring me from the down. So I'm going to see this is the lowest population, followed by this, followed by this, followed by this. But I think the smartest way to do it is just to use this. It's to use this because it's easier to just see based on how low their populations are. And you can see how their emissions are. You can see from N2 it's like 903 tons. If you go to here, you see this is like 459,000 tons. So if you compare the emission, you see that this difference is really so here we can kind of see how population interact with emissions globally, but we're still going to confirm that. We're not just going to use our reasoning, we're going to confirm that logically from our analysis. So that is how we do that. So question number 9. We move to question number 9, and I'm going to create text. So what is in question number 9? It says, in what year was CO2, CH4, N2O, and total GHG emissions the highest? We want to know the year where we have them the highest. Okay. So in what year was, so we're going to do them individually. So we're going to check for N2CO2. In what year was CO2 the highest? In what year was CH4 the highest? In what year was N2O the highest? Okay. So let's just do this and say CO2. We want to check the year CO2. We'll do CO2 first. CO2. For CO2, yeah. We'll do for CO2, then we just say GHG, the main data frame, which is the GHG final. All we just need to do is to group by. We want to see when it is the highest. We do the group by, and there's another way you can do it, where you can just use the max function to use the max function on like the specific year. Okay, the max function for the specific year, you can do that, but I also want to do it this way. Okay, you can just use the max function, not on the year, of course, not on the year. You can use the max function on the CO2 column, and it's going to show you which column is giving us the maximum emission for that specific greenhouse gas, either CO2, N2, or CH4. But in my case, I want to subset by year, and what I'm checking for CO2. For example, CO2. And what do I want to do next? I want to sort the value. I want to sort the value in descending order, so it will give me from the highest, and I want to select just what is at the top. What is the highest? Just what is at the top. So I want to sum all the CO2 per year. I want to sum everything per year, then give me the year where we have the highest across all countries. So we say sum, no, not capital letter. So we say sum. Then after doing the sum, when we have that, and I want to sort the value so that it will go from high to low, then I can pass dot sort values. So you can do multiple, you can join multiple functions. It's so beautiful. Then I'm going to say CO2. Then instead of ascending equals true, which is the default, then I'll pass in ascending equals to false. That is, it's going to give me descending order. And I don't want everything. I just want to see one thing. Then I'll say head is 1. Let's see. Error. Why are we seeing this error? Is it my O? Or where is this error coming from? Okay, say no axis named CO2 for the object type series. For the object type series. Now, the reason it is doing this is because I am trying to sort on, like, I'm trying to sort what is not a data frame. I'm trying to sort a series, and I'm doing it in this form. So remember what we did when we used the other place where we passed in that index should be false. When we said as index is false in the initial one, while we're trying to create a data frame from just one column, of course. When we're creating generation, I think, yeah, you can see we passed this, and because we passed this, it was able to make it into a data frame and not just a series. So we can do the same thing to solve this problem. And this is it. So let's see. Invalid syntax equals, what's happening here? As index, oh, it was passed wrongly into the wrong place. As index is within the group by, yeah, was passed wrongly into the wrong place. Yeah, so that's it. So you can see 2021 is where we have the highest. So I passed it into the wrong place initially. So here now, to get for the other greenhouse gases, all I just need to do is change what we have. So if I want to do for N2O, CO2, everywhere we have CO2, I can just replace it instead of writing the code afresh. So I just change it to that. And I run the code, N2O CO2, you can see. And that's it. For where we have CH4, I can copy the same thing. It's still 2021. Then I can copy the same thing. We have CH4 CO2, CH4CO2, and I just go into the code and replace it with CH4CO2, and I run the code. And you can see for CH4CO2, the maximum is also in 2021. Wow, lots of emission in 2021. And the next thing we want to do is to get the total. And here is total GHG. We want to see what here. Of course, we can easily assume that it will be in 2021 also. You can easily assume that. So we run it and we see in 2021. Yeah, so that's how we go about that. So the next thing we need to do now is to answer question number 10. Question number 10. To know which country emits the highest CO2, CH4, N2O, and total greenhouse gas in 2020 and emitting the highest total greenhouse gas across the years on the average. So we're trying to get it for which one is emitting in 2020. Then we want to check it also which country is emitting across the years on average. So let's do this across the years on average. So I'm going to put the question from where I wrote it in, where I wrote the questions, and paste it here. Okay, question number 10. So what we need to do here is just to subset 2020. That's like the first thing that we need to do. It's just to subset 2020 and say equals GHG underscore final. That is where we are, df That's where we're subsetting from, and we're trying to do where GHG underscore, okay, it's suggestion. So here we are doing equals 2020, and we run. Okay, and we can also so what we need to do now is to sort the value. So we want to know in 2020 which country is emitting the highest of each of these greenhouse gases and the total ones. So that's all we want to do. So in our code, since we have for 2020, all we need to do is to use the sort value strategy that we did the other time to know. We just need to sort the value for 2020 to know which country is emitting the highest, and that's it. So just a sort underscore values. So there are key questions that you want to answer in your data, about your data, that simple functions can get you the answer. So here we just say total GHG. We can try maybe let me do the first one as CO2. So for CO2, we want to know which country is emitting the highest CO2 in 2020. Okay, we want to know which country is emitting the highest CO2. Then we want to get descending order, and we only want to get one value in the end. So we just say ascending equals false. Ascending equals false. Then dot head we say 1, and that's it. So run it to check. So we can see China is the highest country, the country emitting the highest of CO2 in 2020. So we just need to change this to N2O CO2. Let's say N2O CO2. It's China again. Here highest N2O CO2, the highest in CH4. Okay. Now we want to check CH4 CO2. CH4 CO2, which country is the highest? Also China. Then we want to check for total GHG. I mean, this is a lot. Then we have China also. So the highest N2O CO2, CH4 CO2, and total emission is China. So that's how we're able to get China for emitting those things. Now the question we now want to check next is that in the overall average, when we average the total emission of each country, which country is emitting the highest? I mean, you can guess what it is, but which country it will be, but we still need to do it one way or the other. So we want to get it because the second part of the question is, you can see it says and emitting the highest, which country is emitting the highest total greenhouse gas across the years on average. So we say greenhouse gas underscore final, let's go df, then we still use group by to answer that. Group by, then we say group by country, then so in this case we need to also pass as index because we want to sort and check the head at the same time. So we can say as index equals false. As index equals, we only want to see one value, just one country, which country is emitting the highest. So on the average we use main, then we sort the value, then we say dot sort values. So what are we sorting the values on? We don't need to sort the value on anything because the two columns we are dealing with is just the total GHG and the how do I put it now, the total GHG and the in the group by. Okay, that reminds me, I didn't pass in what I want to sum together. So this is the total GHG, GHG. Okay, good, I remember that. So we are still sorting on this, on total GHG, because that's how we want to get it, which one is the highest. So we say total GHG and we say ascending equals false because we want to get the highest, so it's going to be in descending order. Then we say false, and we only want to get one thing. So we're going to say head, then we'll pass in 1 and we'll run our code to see. So you see, still China, still China, still China. That's the total greenhouse gas emission over the year, still the highest, still the highest. Now to question 11, where we're going to be answering. Okay, I think I want to add it as a text. Which country emits the lowest total GHG in 2020 and the lowest GHG across years? So just like what we did over here, that we did for 2020 using the same 2020 data, we're going to be doing that at the same time. So we're just doing it for total GHG, by the way. So we're going to pick this for 2020, just copying this, and we use it here. And total GHG in 2020, that is the least, the lowest. So we just change this to true, or we can just remove it in total. So just change it to true, and it's going to show us the lowest. And you can see to value emitted the lowest total GHG. You can see our total GHG emission over here. It emitted the lowest, and across years, still using the same format, but here we're going to be using the one of across years, total GHG across years. And all we need to do is just to change it to true, so that it brings it in ascending order, that is from low to high, while descending from high to low. And we can query that, and we can see St. Helena across the years from 1994 to 2021, they emitted the least greenhouse gas emission in total. So we move to question number 12. Okay, let me add the question here, and I'll call it 12. Let me see if I label them rightly in the other one. Okay, here is question 11. Okay, cool. Now, what is the global trend of CO2, CH4, N2O, and total GHG emission per year? So we want to see the global trend. And this is where the matplotlib that we imported the other time is going to become of good use. Though this is a Pandas tutorial, but we are using matplotlib just to visualize. Okay, and I've created the plot here. To do that, I created a plot, and I'm going to explain the code for the plot so that it can be clear. So you can see the first thing we need to do is, since I'm saying what is the global trend of CO2, CH4, and total emission per year, so the first thing I did was to get the sum for each year. Okay, the total, since we are doing the total, so it's to firstly get the sum into a new data frame. Okay, so I grouped by year, then the sum of everything in each year. So we get that dot sum, and we reset the index. Okay, then to plot the figure, if you are using matplotlib, you need to define your figure size, how you want your figure to be. Then the first thing is, then we plot each of the greenhouse gases, So that's what we did here. So using this data frame, passing the year, so the year is the x-axis, so this is the x-axis, and this will be the y-axis. This is going to be the y-axis, and we label them CO2, and we add a marker, and I'm going to explain that better. And we repeated the same thing for CH4, for N2O, for this. And the reason we did it this way is because we want to have them as a line plot, that is going to have circles like the dot as each point, okay, signifying what year. And that's why we did it this way. So we're going to be having the 4 lines on the plot, then plot x label, the year we want the label of the x-axis is going to be under as year, then the emission in tons, then the title is going to be global trend of GHG emissions per year. So that is how we're going to be answering the question for number 12. That is, what is the global trend? So we want to see the global trend per year. So we run the code, and you can see So this is the total emission in red, the total GHG, and you can see the CO2 followed by the CH4 followed by the N2O. So since these are in CO2 equivalent, so you can see that CO2 in itself is higher than the CO2 equivalent emission in relation to CH4 and N2O. I think that is why we hear a lot about CO2 and CO2 and CO2. So this is the emission in tons. Okay, so you can see that. So from 1995 to 2020, and you're going to see some things over here. When you get to this point, you will see that around year 2009, there was a kind of drop in the CO2 emission, some drop in the CO2 emission. And also in 2019, I think 2019 should be somewhere here. In 2020, rather, in 2020. And you can easily know why there was a reduction in the emissions. And the reason there was a reduction in the emission is very simple. You can easily know that. And how to know that is simple. There was COVID in that year. So we didn't have so much emission because of COVID. There was no activity across the world. And this is the beauty of data analysis. So you can see how we are able to connect what happened in 2020 to emission. So in that year where there was COVID in 2020, you can see the emissions reduced because there was no much activity compared to the past years. And after COVID, it's increased again in 2021, and that's it. So it's so interesting. So you answer questions with your data, you're able to see things, and you can give explanation based on other information that you can gather. Now we want to see the relationship between country size and CO2. We want to see the relationship between the size of a country and CO2. So we want to know if the area, that is the size of a country, has a strong effect, okay, on the CO2 emission. And we're going to be using what we call the heat plot. We're going to be using the heat plot, or you can call it the heat map. And I'm going to be explaining how we're going to do it. I think I'm going to do it stepwise for clarity's sake. I'm going to do it stepwise. So this is question number 13, and that is what we're trying to do. Now, to do that, to do the heat plot, we're using Seaborn. Using Seaborn, and we imported Seaborn already. And if you don't have Seaborn imported, you can just say import Seaborn as SNS. It could be, you can call it PNS, it's your choice. Okay, but remember that whatever you use is what you use to initialize the Seaborn whenever you want to use it. So, but I mean, let's do the common thing, making it easier for all of us. So SNS. Now, to do heat plot, we need to select what our column of interest, the column of interest, the columns that we want to correlate together. So we can say column of interest, column of interest, column of interest equals to, then we specify all the columns I want to correlate. That is, we want to correlate area, CO2, CH4 CO2, N2O CO2, and the total greenhouse gas emission. So I have them somewhere here. I have them copied already, and I'm just going to paste it. So you can see these are the columns of interest. The columns of interest. So let me just say columns of interest because it's more than one column. So the next thing that we need to do now is to now subset our data frame, have a new data frame based on this column of interest. So we can just say subset, and we say subset data frame. We create a subset of the data frame based on the column of interest. So we now say GHG final underscore final this. Now we'll pass in column of interest into it, making our life easier. It's just as the same as I could pass in everything here directly here, but just making it interesting for all of us. And that's the first thing, we subset it. Now we do the correlation matrix, because for heat map to work, for the heat map to work, we need the correlation matrix, and we can say correlation matrix, correlation underscore matrix And to do it is very simple. That is, correlate the column with each other, and we're going to interpret the heat plot when we get it. So we say subset correlation matrix, and the next thing we want to do is to do correlation. You just pass in the correlation function, CORR. That's just it. It's so straightforward. And we can print the correlation to see before we plot the heat map. So let me say print correlation matrix. I want us to see what the output will look like. Now you see, this is the correlation matrix. But the way it is in this way, I mean, when you see 1, 1, 1, I mean, it's talking about the same thing. So when you correlate the same thing with the same thing, it's surely going to be 1. So if you want to correlate area with CO2, so just trace it, and this is CO2 and area. They are correlated with each other, 0.59. So area is influencing CO2 at 0.59%, or yeah, you can say 59% effect on CO2 exactly. So it's the way area contributes to CO2 is different from how it contributes to CH4CO2, different from how it contributes to N2CO2. Yes, we can say there's some level of correlation, especially positive correlation. Depending, of course, it depends if CO2 emission is a bad thing. So we can say, I mean, it's a negative effect in essence, like the size of the area is contributing to more emissions. How do I put it? There's a way we can interpret that by saying that based on how the situation is, okay, it's like a negative thing, but mathematically or statistically, there's a positive relationship. That is, when area increases, emission will increase, and that's it. But not extremely strong correlation. Like it's not like 0.9, right? It's still like 0.66, 0.65, and like that. Even on the total GHG at large, it's like 62%, like 0.62. But to see things very well in a colorful way, that is why we use the heat map. So let me just say create heat map over here. Create heat map. That is why we use the heat map. And to do that, we just say plt.figure. Remember, where is this plt coming from? When we, let me go up so that we can see. When we imported matplotlib, you can see we use plt as plt. So if I use this as dlt, I'll be calling dlt down there. But the way it is done in the common way is to just use plt. Okay, so just do what is, should I call it standard? What is the generic thing to do? Okay, so coming back here, now I'm specifying my figure size. I'm going to say fixed size, and I'm going to pass in, say, 10 by 8. That is going to be 10 width and 8 height. Okay, and the next thing is going to be to now use Seaborn, the SNS here, to plot the heat map. So I used the matplotlib plotter figure to define my fixed size. Then I'm just using the function of the heat map from Seaborn. So you can mix when you're working, when you're plotting in Python, you can mix matplotlib and Seaborn depending on the specifics of what you're doing. So heat map, and you just pass in your correlation matrix, this exact thing. So you want it to work on it, then you pass it correlation matrix. We want annotation. And what is annotation? So let me do this without annotation so that you can see. Okay, let me do this without annotation. You can see without annotation. So what is the annotation? Sorry, what is the annotation here? The annotation here is the text, that is all these values, I want them to show on the plot. Okay, so when I pass in annotation, for example, I'm going to pass in annotation, and I say annotate equals true, you're going to see what will happen. I pass in annotate equals true. Now, do you see we now have the text on it, the annotation of all the values. Now, another thing we need to do is you can define the color of how you want things to be. You can define the color. And another thing you can do is you can specify like how you want the significant values. For example, if you have 0.59, 0.68, you want to have this also as 1.00. It just makes your plot so good to look at, and you can also define like the color map, like I was saying the other time. So one of the ones you can use, it is not compulsory, you can just leave it this way if you can interpret your data. So I'm just going to use the cool worm. It's one of the color maps with Seaborn. Let's see what happens, and you see that's it. So you can see the color palette has changed. Then FMT, so here we are using the FMT parameter to pass into say, oh, I want this thing to just be two decimal places, okay? So, or two significant figures, as you may want it to be. All right, so when I run this, you see, so you can see I'm having 0, 0, 0, 0, 0, like everything is in two places now. 1.000, 0.59. Okay, then it is showing without using the plot.show, but I want to add a title to my plot, title, and I'll call it correlation heat map between country size and GHG emission. Okay, or just a correlation heat map between country size and GHG emission. So this is not a visualization course, so or tutorial. There'll still be another video in the future that I'm going to be recording on that, talking about each Seaborn, Matplotlib, and all other ones specifically. But we're just doing this to understand for just analysis. In this case, I'm not going deep into explaining the visualization. All right, so you can see well labeled now, correlation heat map, and we have it. So we've been able to answer question number 13. Now we're going to the second to the last question, which is question 14. And what is the question 14? It is also a critical question, which is, okay, let me add it as text. It is also a critical question to see what is the relationship between population, area size, with CO2, N2, and everything. All right, that is the next thing that we're trying to do. So we want to see population. We want to see population. We want to see the area size and how all these things relate. Okay, what is the correlation of population with all the emissions? So we want to put these two things. What we've done in number 13, all we just want to do is to add population to it. All we just want to do is to add population to it. So all that we change is just to have one more column of interest. One more column of interest. And we can copy exactly what we've done here to do that and just add population. Sorry, I did copy on empty stuff and trying to paste it. So we can reuse the code instead of doing it afresh. So we can just add one more column and call it population. So the population column from our data frame, the population column, we are adding it to this, and we can just say between region size. I can remove let's say, so we want to see population, area size. I want to see them together in the same plot. Okay, now we can just run it, region, the region and area size, So you can see this. Now, does region, the region of the country, emissions, is it is there a correlation between the region in the world, a region in the world, and the emissions? So here we could see that not region now, I'm talking about population. Am I talking not region? Population, not region. population. So where the population, what is the impact of population on greenhouse gas emission? Now, when we look at population, for example, here, let's use down here. Now, when you look at the impact of population on total greenhouse gas emission, it is like 0.78. But when you look at area or area size on total greenhouse gas emission, you will see that it is 0.62. That means there's high correlation or higher correlation between population and total greenhouse gas emission compared to area. So a place may not be so big, but if the population of people living there is so much, there is potential for increased greenhouse gas emission. And if you look at it, look at area, for example, up to N2 CO2 emission, you can see 0.66, while population has 0.88. That's like 88% on it. Now look at CH4 CO2 0.91, 0.73. So we can easily conclude here that when you compare area and area size and population has so much effect on total greenhouse gas emission than the effect size of an area or the size of a country has on the total greenhouse gas emission. So there are chances that a country could be small and be emitting more than a bigger country if we have more people living in the small country. So that is an insight that we get from this part of the analysis. Okay, so the second part, which is the part B of the question that we are dealing with, which is the part B of the question, is the part B here. Let me read the question. And what is the trend between region and CO2, CH4, N2, and total greenhouse gas emission? That is the other thing that we need to answer. So to do this, now we're going to use we're not going to use like the full data set yet. We are not going to be using the full data set yet. Okay, so what we need to do now is, before that, let's do the question directly, then we're going to come back to do the other thing. All right, so let me just say part B. I think I should call it 14B. Let me call it 14B. And what are we trying to answer here? We are trying to get what is the trend between region. What is the trend between region and all the emissions? Trend between region and all the emissions. We just want to see per region what the emission is in each region. So that is what we are trying to do now. So a simple plot that we could do is we can just say plot figure. In this case, I want to compare the region, so I'm not going to be using the kind of plot I used before. Here now, I'm going to be using a bar plot to achieve my result in this case. So the figure size is equal to like just 12 by 8. Okay, and we could actually reduce it to, let's say, 10 by 8 or 10 by 6. It's not written on stone. It depends on what is convenient based on your screen size. Okay, now I'm still using Seaborn. I'll use SNS dot bar plot, where x is equal to the region. So region as titled in our data. So, and y is equals to total GHG emission. Total GHG emission. Okay, so we are doing it for the total greenhouse gas emission. Okay, total GHG emission, and the data set that we are using is our GHG underscore final DF. Okay, now we may have an issue here, but I'm gonna point it out. Maybe let's just do it directly first. Let's do it directly first before we know what is before we can completely tell what is going on. All right, let's just do it directly first. Then confidence interval, we are saying none. Don't add any confidence interval. Then the palette, we'll just use, we can use any palette. You can easily see palettes in Seaborn, inside the Seaborn library on the palette, and you can generate your own palette, of course. Then palette, I like this one, Verdis or Viridis. Yeah. Then we can just plot. Let me just say, let's add label. Let me just say plot.show, plt.show, plt.show. Now look at this. Just wait for it to plot. Now it's returning an error. It's saying total for y. Okay, that was GHG. Okay, now you can see, but you can see it's kind of a mess. We can't see things as they should be. So that is what we're going to be doing next in our plot. Like I said, this is not a visualization tutorial, but it is good that I show these basic things so that you can, analyze your data better and answer questions from your data. Now, what we need to do next is to, let's label things. I'll just say plt.x label. That is to label the x-axis, and we call the s label, that's our regions. Let's say regions, and the y label, .y label, we call it total emissions in tons. Yeah, total GHG emissions in tons. Total GHG emissions tons is in tons. Okay, then the title, we give our plot a title, plt.title. Let's just call it total GHG emission by region. Total GHG emission by region. Total GHG emission by region. Okay, now we can view our plot again. You can see everything, we're well labeled now, but that is not still enough. We can see that we can't really see all the regions very well over here. So what we need to do next is a very simple task that we need to do. And what we need to do is to use another, should I call it a function now, which is xticks. And what are we doing with xticks is we are dealing with the rotation equals 90. So we want it to be in 90 degrees. I want it to turn towards the right. Okay, because the right, and we run that. You can see we run that, and you can see that we are having some kind of like error. We're having some kind of error in our data. We're having some kind of error in our data. Like you can see the space. This shows that there's space in the data set. This shows that there's space in our data set. So we need to clean our data. We need to clean it. There's space in the data set, and we need to clean it. So if you look at this, you can see it shouldn't be this way. And you can also, if you want to turn it to 45 degrees, you can turn it to 45 degrees. And yeah, slant, but there's space in our data set. So beforehand, what should we do? Let's clean the data. We need to clean the region. So we need to go to total GHG. That's our data frame here. And what we need to do is to clean region. We need to clean region of every space, just like we did in the beginning for the other part of the data set. So we just say this region, and what we're going to do, we use the str and we strip. We do the strip, and let's run our code again and see the difference. Now, do you see it's closer now because we've been able to clean it. All right, so another thing I want to do is to add the how many countries are in each region. So in North America, in Baltics, so I want to add it to it. But to be able to do that, if I check region, for example, and I check the unique values, it's not going to give me the exact value count. So if I say value underscore count for region, Now, do you see? It's showing me that in Sub-Saharan Africa, we have 1,204 and everything. Now, the reason for this is very simple. The reason for this is very simple. It is because our data set, we have the region repeated in like multiple places. So it's just counting the rows where they occur. But if we select the data for just 1 year, in 1 year, the region is only occurring one time. So when it is counting, it's only going to count the number based on the number of countries that are in that region. So that is where we want to select from before we use we label our data using it. So I want to have label where on each of these things we are going to have how many countries are in those regions. So that is what we want to do next. So I'm going to select just 1 year data and use it. So remember we created a data frame for 2021. We created a data frame for 2021. So I'm going to use 2021 instead of GF final for the value counts. And you're going to see an example of what I'm trying to do. So I will say 2021 region. If I say value count, now look at this. Do you see? Because it's occurring each country is occurring once, so it's able to count it accurately. So in Sub-Saharan Africa, there are 43 countries based on this data set. In Northern America, there are 2, in Baltics 3, and like that. So we're going to do the labeling. And to do the labeling, we're going to be using our GHG 2021. Okay, so how do we go about that? It's also very simple. So within the same place where we're making the plot, we're going to create region count. We want to get the count of region underscore count. Then we're going to say equal to GHG 2021. Then we pass in the region. Then we need the value count, of course, dot value underscore count, and that's what we want to use. Okay, then we write a simple for loop in basic Python, just a simple for loop. So we can say for hi and count. So we just initialize that and we're saying enumerate, then region count. So we want you to use the region count here, and we now want to do plt.text. That is, we are saying add a text to the plot. That is what this function is for. Then then it will check the count. That is, it will go through region count, then check which position, that is what is the index of the value. So it's going to check that index, then whatever count is there, to paste it in the appropriate place. Okay, now we are plotting it and say count, then str count, so that is, use it as a string, whatever the count you have, so that it can paste it as a string. Then we set the position equals center, and that's the horizontal position, and the vertical position we set it as bottom. And is that set rightly? Yeah, VA. Okay, there's something wrong here. Okay, yeah, okay, because I just know there's something wrong. It's supposed to change color and it's not changing. Then we can set the font size also, and say the font size equals 10. So let's try to plot and see if it won't return any error. Now look at it. But there's a challenge. What is the challenge? In our data, Sub-Saharan Africa has 43 countries, but here Sub-Saharan Africa is having 14 countries, while Asia is having 43 countries. So something is wrong there. And what is happening there? Drum rolls. If you can guess what is happening before, of course, you watch the next part of the video where I'll be talking about it now, you can put it in the comment section, like I got it first, and that'll be good. Who knows? Maybe there could be a reward for anyone who got it first. Okay, but be truthful. Okay, so the problem here is that this is not sorted. the value count we are using is not a sorted value count. That's one. Two, we didn't sort our data frame at the same time. So it is not sorted on the region. So because they are not sorted, it is unable to align which region belongs to which count on the plot. So all that happened on this plot is that it just took this value one by one, it went through it one by one and just spread the value across in this order. So it doesn't matter if North America is 2. So far, the last thing is Baltic. It just placed 2 on the last thing. And that is not what we want. So all we need to do is just something simple. Because this is not, because when you do region.count, the region becomes the index. So to sort this, you just say dot sort index. And that's it. Dot sort index. So we want to sort on the index. That's it. You just say sort index. And that's it. So it's going to sort index. Now for the data frame, our data frame, we also need to sort our data frame. Then we use sort values and we sort it on region. Sort it on region. So in the last time, we sort this on index because automatically region is the index. So here we're going to be sorting based on value because region is a value, is a colon of its own here, not the index. So when we run it, we're going to see what we have. So you can see that everything is in order. So you can see North America is 2, Sub-Saharan Africa now has 43 countries. Now, if you look at this plot, let me try to maybe reduce the size of this plot. Let me say 10 by 6 and see something. Okay, all right. So now if you look at this plot, you will see that North America has just 2 countries. 2 countries. However, they are emitting more. Just 2 countries in this region. Now, if you come to Sub-Saharan Africa, we have 43 countries and we're not emitting as much as 2 countries in North America. And like that. So you can see that this will help you to know if you want to take, as we take action on global greenhouse gas emissions, we will need to look at how much are we contributing, either per region, per country. If you are looking at continental level, per continent, how are we really contributing to this? And that will determine our contribution to mitigating climate change, our contribution to mitigating emissions. And that is very important. Okay, so based on this data set, this is what we have in relation to the total greenhouse gas emission, in relation to the total greenhouse gas emissions. Okay, now that's by region. So what do we want to do next in this case? What do we want to do next in this case is I'm going to show us something that is like really paramount. Now, if you look at the way our label on our plot is, look at this. It's really difficult to know if this is million or billion except you count all these values, like signifying like it has 9 zeros. It's really difficult to know, okay, is this 500 million, is this 5 billion? So we can easily sort that in our plot. We can easily sort that by just adding a little thing. So there's a library called func formatter within matplotlib. So func formatter, so we're going to import it. All right, just adding it to this. So we say func formatter, so just import it from matplotlib.tk, import func formatter, function formatter. Then we're going to pass in like define a function using that func formatter. Okay, so let's define a function. That is the function we are creating now is just to specify how we want the output to look like, how we want it to what we want the value on our y-axis to turn into. So let's just say func format. We want to format it. So we say format underscore function or func, whatever I want to call it. So the function will receive a value. This is how you define a function in Python. The function will receive a value and also receive a tick number. Okay, number, and that's it. Now, what are we doing next? Simple. So we're setting a condition and saying if the value is greater than or equals to 1 exponential 9, okay, we're saying return, then we use the string, return the value will be divided by 1 exponential 9, and the value is going to be, it's going to have a label B, like signifying like billion in front of it. Okay, it's going to have signifying like, 6 zeros is million, 9 zeros is that's billion. So it's going to have it in front of it. Then the next thing is, okay, elif, that is else if, depending on the programming language you're using. So elif value is greater than, just like what we have here, but we're just going to be having it as greater than or equals to, now I want to define it for the million. So we say 1 exponential 6, that's 6 zeros. Now return, we use string again, and within string we pass in value divided by 1 exponential 6. Okay, and that is going to give us million, whatever it is. Then else, oh, my return is spelled wrongly, it's return. So say else, just return the value as is. So return string of the value as it is, return the string of the value as it is. So how do we want to use our function? Okay, this is where the func formatter is going to come in. Okay, so it's going to look at our condition, it's going to take in this function, then use it within the func formatter. All right, so just say plot.gca, then .y-axis. So remember, what we are trying to work with is the y-axis. So we're going to specify the y-axis dot set major formatter, then we pass in the func formatter, the func formatter, and within the func formatter we pass in our function that we define here. Pass in a function that we defined, and that should be it, and we run our code. Now look at it now. Instead of using the exponential thing, now you're able to know 500 million, 1 billion, 1.5 billion, 2 billion, 2.5 billion, 3 billion, 3.5 billion. So it's easy to see that. So that's what we have based on the data set. That's what we have based on the data set. So we have a clean plot. Okay, so this is interesting, and that will lead us to the last question of this analysis. So question 15. So if you have been enjoying this tutorial and you've been learning something, I'll be glad if you could comment, I'm learning something, and you could share with your friend who could benefit from it at the same time. And remember, if you haven't subscribed, you can subscribe to the YouTube channel, and much more. You can click the notification bell to get updated whenever we release new videos. Okay, now in question 15, what are we to do? It says in 2021, what is the relationship between age group of a population and the average total greenhouse gas emission between the countries where generation D is the greatest, countries where generation C is the greatest, countries where generation B is the greatest, and countries where generation A is the greatest? Okay, so compare them to understand if having more population of a specific generation impacts emission. So use top 10 emitting countries as examples in this region. So what are we trying to compare here? There are countries where you have more people that are generation A, for example, old people. So, and you have some countries where you have younger people. So I want to compare it, like what is the emission like in countries that are dominated by younger people and countries that are dominated by older people, like from adults to older people. So, that kind of comparison among the generation, or you can call it the age group of people within the country based on these data, based on the data set that we have. So to solve this kind of problem, the first thing that we need to do is to get those countries where the generation D happens to be the highest population. We need to grab those countries where generation D happens to be the highest population. We need to also get get the data frame, that is the countries where generation C happens to be the highest, where generation B happens to be the highest, and where generation A happens to be the highest. That is what we will be doing next. So get ready for this. So let's subset. So generation D countries, like I said the other time, there are multiple ways to achieve the same thing, but I try to go through the seemingly simpler way so that you can understand like the process. And as you do this on your own over and over again, you solve different kind of problems, you understand how to do them better. Okay, so we are dealing with the year 2021. Okay, in 2021, right? So we already have the data frame of GHG 2021 already created. So all you just need to do is to filter it based on that and say GHG 2021 generation D, where generation D, now what are we doing with generation D? We want to check where generation D is greater than all other generations. So to be able to do that easily, normally you can write say where you can do it this way, like where generation D is greater than generation B, and generation D is greater than generation C, and generation D is greater than generation A. You can write it that way, but that's a kind of a long thing. So what we can do is to pass all other generations into a list, then get the maximum. So all we just need to do is to compare the maximum of the other three generations with generation D, and if generation D is higher, it's going to grab the data frame and store it into generation D countries. But if generation D is lower, of course, it's going to ignore that. And that's what we're going to do. So what we need to do now is to use within our data frame of GHG 2021. We'll do this and select all other generations. In the place, like generation A. So let me just copy so I don't have to type that much here. So I'm just going to copy this over and over again and say, okay, then I'll just change it. So this is D, and I'm just going to have A and B and C. So we're trying to see how D is greater than A, B, and C. So after doing this, after subsetting them, still within the same, how do I put it now? Still within the same line. Okay, I'm trying to put everything in on the same line. So let me do this. Sorry about this. Okay. All right. So I think that's just a thing in Google Colab happening. Okay, so within here now, I will grab the maximum using the max function. Using the max, I'll grab the maximum. After grabbing a maximum, I need to specify what axis am I trying to get the maximum. Is it the row or the column? But it is on the column. So axis and equals to 1. All right. Then when I grab information, remember, whenever you subset, try to reset the index. Okay, so that everything is clean. So I'm going to say reset index and drop equals true because I don't want you to create a new column for the index we reset. So drop equals true, and I'm going to run the code. Let's see. Now, these are successfully shown us generation D countries. So let's see how many we have. So you can see that now we have 103 countries that are generation D, 103 countries that are generation D. That is where generation D is greater than all other generations, those countries where we have it that way. So to do this thing for the other generations, let's not reinvent the wheel. We can just easily adjust the code. So for generation C and A, so here we say generation C, generation B, generation A, and we just go here and say generation C, and all we just need to do is where we have C here, we change it to D. Same here, where we have generation B, change this to B. And that's why it is good when you are naming that you should use a very good naming convention so that you can easily edit things and move faster. And when we have B here, we pass D there. And under generation A, so we have A here, and where we have A before, we change it to D, and we can see. So everything cool. So let's check generation C countries. How many countries are there? So we have 63 countries, okay, where people in generation C are the highest population. All right, that's interesting. So let's see generation B. So no one. So we don't have any country where generation B is the highest. That is people that I think are above 69 years old, where they are the one dominating the population. Okay, then generation A also, of course, we're not going to have any in that regard. So our analysis is going to be based on generation D and generation C. That is what we are going to be comparing. All right, that's our comparison will be on. So what is the next thing that we need to do? I just want to show us something, a small tip from our dataset. Which is on how we organize our data. So I'm going to go back to the 2021 data that we are using. I'm going to load it. Then just to show you how to move, how to move columns around, how to move your columns around. So if you check GHG, you will see that N2O, CO2 population, N2O, CO2, CH4, CO2, they are together, but our total emissions is somewhere at the back. So I want to show you how to move this before we conclude the analysis, because all we just need to do to conclude is to have a beautiful plot. Okay, is to have a beautiful plot. All right. So now to finish the analysis before we make the final plot, I just want to show you how to move the columns around. And how do you do that? So I will use the generation that's in 2021 as the example. And if you see that our total GHG is behind. So how do we solve this? It's very simple. So let me call this rearranging columns. A lot of times what people do is they just reselect the column in the order that they want it. Like you just reselect the column into a list in the order that they want it, and it's going to follow it. But that's more like a long journey. You can easily do this. Specify which column you want to move. I want to move global greenhouse gas, and I want to move total greenhouse gas. For example, this is what I want to move. Okay, I specify the column of interest that I want to move. All right, now the column of interest I want to move, I need to remove it out of the greenhouse gas data 2021. So how do I do it? It's simple. You just use a pop function. So what I'm doing is that I'm popping this out and storing it here. So from GHG 2021, remove this column and store it here for now. So after popping, you then insert. So to move column around, you use what we call pop and insert. You can even turn, you can make a music out of that. Pop and insert. Pop, that kind of thing. Okay, just trying to crack you up. If it is funny, let me know in the comment section if I'm so funny. All right, so GHG 2021. So within it, so we want to insert it back into GHG 2021, we pop it, then we insert it. Dot insert. Okay, then we specify what are we inserting. The colon, we're inserting the colon that will pop out. But before that, we need to specify the position. Which position do we want to place it after, after popping it? Where do we want to place it? So we want to position it after CO2 because it's the total. So we say country plus year plus N2 CO2, like we need to count it, country. So this is going to be 1, 2, 3, 4, 5. But in our analysis, in what we are doing, we cannot place it in 5. Okay, we cannot place it in like 1, 2, 3, 4, 5. We're not going to count it that way. So if we want to count it well, it's not going to be 1, 2, 3, 4, 5 and place it here like that. We're going to say 0, 0, 1, 0, 1, 2, 3, 4. So it's going to be the 5th position. Because if we count from 1, 2, 3, 4, 5, it's going to be the 6th thing. But we don't want it that way. So if you're counting, you count from 0 in Python. So it's going to be 0, 1, 2, 3, 4, 5. So we want to put it in the 5th position. That's before the population. So we're passing 5 here. And what are we saying? Then in front of the column, you need to add column name. You need to add a name to it, the column name. This is a parameter that you pass in into the insert. Okay, then you pass in the column in itself. So then let's see what happens. Now let's check our GHG 2021. So you see, we have total GHG. So everything is together now. So that is what I want to show us. That is what I want to show us. Now to answer the question. We have our data, which is the generation D countries. We also have the generation C countries. So we want to make the plot to see how is their emission like when you compare them. How is their emission like when you compare them? Okay, are you ready for this? All right. So to do that, it's also very simple. And that is the last thing that we're doing in this video. So the first thing we need to do is, since we are working with the top 10 countries, okay, within each generation, you can see, use top 10 emitting countries as an example in each generation. So in generation D and generation C, we're going to use the top 10 countries as examples. We're going to use as examples. So the first thing we need to do, let me make this a bit neat by creating more space. So to select the top 10 countries. So let's say top 10 generation in generation D, top 10 generation D, top 10 generation D is going to be equal to, just to subset the top 10. And how do we subset the top 10? Before, when we're checking top 10, top 5, we just use head and tail, but there's another way that we can subset things. Based on how large or how small, how it is. But here we are dealing with the large. So we just select our data frame, which is generation D countries, because that's what we are doing here. To select the top 10, you can use another function called n-largest. N-largest. Then in n-largest, you select how many you want to pick and what are you using, what is the variable that you want to select them through. So we want to select them, that is the 10 largest total GHG. So you pass total underscore GHG, and that's it. That's how you select the top 10 generation. And you just do the same thing for the C, because we don't have anything for generation B and generation A. So it's going to be C, and you just say C plus countries, and you can do that. If you check the data frame, it's just going to show you the top 10, like top 10 generation D, and you can see only 10 is going to show. Only 10 countries is going to show. So that's it. That's what we're trying to do. Now, the next thing we need to do here is, since we are plugging, we are plotting two figures, since we are plotting two figures beside each other, we need to use what we call the subplot in Matplotlib. So we define our figure, we open our figure, and this time around we need to have axis. So axis equals plt.subplot. This is going to be well explained when you watch a visualization tutorial. That is going to come in the future. And maybe you are watching this video after a long time. The visualization video is probably already on my YouTube channel. Okay, so fixed size equals 15. It depends on you, the fixed size you want to define. And one of the things we need to do that is very paramount is that we want the figure to share the same y-axis, because that's how we can compare. If they share different if they share different y-axis, if they don't share the same y-axis rather, it's going to be confusing if they don't share the same y-axis, because it could be the maximum value on one y-axis could be, let's say, 1 billion. And the maximum value in another axis could be 500 million. And when you see the plot, it's going to look like they are equal, but the values are different. But when they share the same y-axis, it is easier to compare. Now, fig axis and share, we had it. This function, this is share y. You can see you can also share the same x-axis, but in this case, we are sharing y-axis, and say true. And that is the first thing to do. Now we make the first plot for the first generation. So we say sns.barplot, where x is going to be the country, y is going to be the total GHG emission, and the next thing we need to do is that data, where we're getting our data from. Then we're dealing with for D, right? So we are plotting for D first. So let me say generation D. Let me call it plot for generation D. Okay, interesting. Now we specify that we have the data. Now which axis we want it to be? We want it to be the first axis. So we can say AX is equal to axis 0. So it's going to be the first thing. So if it's axis 1, it's going to be the second thing. But 0, then we want the EU to be like color based on the countries. We want them to have different colors. Okay, so it's just for easy visualization, to just see things clearly. And which palette should you use? Like we used this Viridis the other time, so let's just use it again. Viridis. So you can see it in Seaborn color palette. It's there somewhere on Seaborn's website. Then we don't want to add legend, so let's just say legend equals false. We don't really need it that much. Okay, that's just the plot. So the next thing are just like decorating the plot. So now that we are dealing with axis 0, all we just need to do is set the title per axis. So we can say axis 0, the title. Initially we use PLT because we're dealing with one plot, but here we're dealing with multiple plots. So we just say axis title. So we can say top 10 countries in generation D. So top 10 countries. Emission of top 10 countries. Let's just say emissions of top 10 countries. Maybe that's just, let me just say generation D. Yeah, easy. Generation D. Let me make it easy. generation D, generation D, and yeah, that's it. That's just the title. Then we need to add the label of the y-axis to it. So what would be the label of the y-axis? So you still use the same thing as a 0. Then you're going to say dot y label. So what should I label the y-axis with? So it's going to be the total emissions. So that's total GHG emissions. Total GHG emissions. And we want to rotate the tick label, just like what we did initially. We want to rotate them so that everything, we can see it easily, just like what we did before. So we want to rotate them. So using the same as a 0, we want to rotate it. So we set our y label. The next thing is to set the rotate. So we say the tick parameters. So we say we want to rotate the ticks. So we take tick params, right? And we just say axis equals to x. Okay, the x-axis that we want to rotate, and we say rotation equals to 45. That is, rotate the x-axis at 45 degrees by 45 degrees. So we are doing the same thing basically in the next plot. When we are plotting for generation C, we are doing basically the same thing. So we say plot generation C, and for generation C, I'll just copy and paste the same thing, then change the data frame and the axis number. So here now it's going to be top 10 generation C, just like what we have here, top 10 generation C. And I'll change the axis because I want it to be second thing, and change this to 1. I wouldn't need the y label because we are sharing y axis, so there will not be need for another y label here because they are sharing the axis. Now let's see, to compare if the generation that is the most populous in a country has effect on the total greenhouse gas emission. Okay, now plt.show, and we'll plot and see what is wrong. Title object not callable. Okay, object not callable. The title, let me see, text object not callable. So there's a problem with how I did this. Oh, okay, yeah, it is set title, not just title. So it is set title, set title. So let me run it and see what happens. Axis has no object y label. Axis has no object y label. Just like it is set title, it is set y label also. Set y label also. Yeah. Then I'll run it again. So these are some errors that we encounter when we are running our code. Okay. So what is happening here? In this case, generation D. This is not what I was expecting to have in my data. Something must be wrong somewhere. Something must be wrong somewhere. Let's see. Okay, the top 10 generations. The n largest 10. So we'll walk through the code from beginning. That is not what I want. Okay, now I could see where the problem is. Now, instead of share y-axis, I used share x-axis. We only want you to share the y, not the x. So let's do it again and see. And perfect. Everything clean. Now we can see that the countries with generation D kind of emit more. Emit more where generation D is dominant. So we can easily or somehow conclude that the age group of people within a country has an effect on the total greenhouse gas emission. So, I mean, there are also other things to consider before you make the final conclusion. But based on this, I mean, at the fundamental level, we can say the generation of people that live within a country has some level of impact on the total greenhouse gas emission. Wow. So thank you for staying through the old tutorial, okay, from the introduction to pandas part 1 and the second part of it. I hope you've learned something and you can just get your hands dirty and try it. The way to learn is just to try. You can just repeat the same thing I've done, make your mistakes. Even while doing it, you could see that I made mistakes too. So that is just simply how it works. So I'm going to say thank you once again, and if you are yet to subscribe, like the video, and also click the notification bell to get notified when new videos are being uploaded. So thank you very much. See you sometime again in the next tutorial.